Okay, problem 5. It's the same data set, but now instead of calculating an average return, they're having you calculate the standard deviation of the return, or the variability or risk of the historic returns. So thankfully, Excel has a function for that. And so all you got to do is just type an equal sign and start typing what you think the function is going to start with. And sure enough, by the time you get to the letter T, it'll give you, it'll prompt you for the standard deviation function. Yours might not prompt you quite as quickly as mine did because it's picking up what I've used before, right? But our standard deviation, and then you just pick up the numbers that you want over here, and there it is, 1.711. We want it in with 3 decimal places. So I'll tell you what, I'm going to copy this across before I start filling in the answers over here. So this is 1.711. And the long-term government bonds is 10.960%. And large company stocks is 14.736. Okay, and so you see that large company stocks had the highest variance. And what that means is, although they had the highest return, they also had the highest risk, which is what we would expect to see based on what we've learned in this chapter. Okay, great. And the lowest variance was in the T-bills. There it is. Okay, this one I want to note that I had to spend a few minutes getting it lined up so that not only so that you could see it, but so that you could tell what they were asking for. So here's the setup. Hull Consultants, a famous think tank in the Midwest, has provided probability estimates for the 4 potential economic states for the coming year. The probability of a boom economy is 12%, the probability of a stable growth economy is 20%, and the probability of a stagnant economy is 52%, and the probability of a recession is 16%. So estimate the expected returns on the following individual investments for the coming year. Okay, so here is, and then what you do is you grab this table and you can copy it right over into a spreadsheet. What I did was I copied it over into a new spreadsheet. So this is a whole new page. So you see it's showing when I downloaded it. So that's how that works. Now, the other thing that they say is to make sure to round all intermediate calculations to at least 7 decimal places. That is not an issue, obviously, for spreadsheets. They do it to, you know, as many degrees of freedom as we need for them to. What they're doing is making sure that people that are doing it on a calculator are not overly rounding, I guess I should say. Okay, I just returned from having cut the video as I was muttering to myself and trying to get this thing to format properly for you to be able to see it. And so I want to note that something that you guys might not be aware of. You see how there's a darker line here on the top between lines 1 and 2? Well, what that means is that the formatting for the spreadsheet, which I didn't do, but whoever set up the spreadsheet in the first place at Pearson, set it up so that line 1 is always visible. So no matter where you go, you can still see line 1. So if you find yourself losing your data, which I just did off camera, that's what was going on. So there you go, little Excel trip. All right. Let's see, I'll make this all big enough so that we can see it. You see what happened? Right now, I lost those first couple of lines. And what I did off camera a minute ago was like, where the heck did it go? Right, but there it all is. You just gotta find it. Okay, so anyways, I want to note that these returns, right, this table that is provided is the percentage returns, but we also have to look at the probabilities for the what are called states of nature. States of nature. So they give us over here that the boom economy is 12% probability. Let's make these percentages. And the stable growth economy is 20%. And the probability of a stagnant economy is 52%. And the probability of a recession is 16%. So the first thing I want to note, these numbers add up to 100, right? You can see down here, the sum is 100. Okay, and the way that you calculate this, we're going to calculate it out bit by bit, just to make sure that it's clear how it works. You'll see I've already completed the first one. So let's see. So our well, the way that you calculate the expected return is it's the sum of the probabilities of the states of nature times the return, right? So let's just calculate each of these subcomponent pieces. So it's the probability of the state of nature. Now I'm going to make that row an absolute cell address so that I can copy my formula down in a minute, times the return. Okay, now, watch this. Now I can just copy this across, like that. And then the sum of all of these is going to give us our expected return. So that's 5.48%, which I've already tested my procedure on for you off camera. But now, guess what? I can copy all of this down and we'll get all the answers for the rest of it. Okay. So our expected return for a corporate bond is 6.44%. And our expected return for a government bond is 5.44%. So interestingly, I want to note something about that, because we always think that government bonds are such a, low return investment because they're so safe. But given that stocks in this case, right, this isn't necessarily reflective of reality, but what you have here is, an economic consulting firm that says we really think that that the economy is going to be stagnant, 52% probability that the economy is going to be stagnant. And we know that for this particular stock, or maybe for this particular class of stock, if the economy is stagnant, they're only going to grow at 2% a year, right? So if the economy is really good, stocks are a great bet. If the economy is lousy, stocks are a terrible bet. But even if the economy is just kind of chugging along, stocks are really not all that much better of a bet than bonds, corporate bonds anyways, in this particular situation.